So you got a test.
How do I zoom in?
What?
Test.
You don't. He just.
No, I don't.
Don't zoom in. He'll fix everything.
Okay.
Alright, so just to see if people digested what we were talking about yesterday, which no one watching this would know about if they were in class or whatever.
2x.
So, I would like someone to tell me the derivative of the thing I'm about to write on the board in... No, I'll be nice. Come on, Jeff. How about 5 seconds?
5
Maybe 3. Let's be 5. We'll do 5 seconds.
Just write it very slowly. Write it slowly, Lower. I can't even see it.
I give up.
What's the derivative?
Sine 1?
Is
that sine 1?
And then what else is the parentheses?
Yeah, it's sine.
That's it, that's the sign of 1.
Sine 1.
So that's like
What's the derivative?
No.
No.
That's 1.
Sign 1.
The whole parentheses.
yeah, that's it.
The whole thing.
Label it Y.
And then to the sine minus 1. Times 5 plus pi squared plus 7 over 7.
Yes, that's the derivative.
I would have done that.
I knew that. I would have done that. Me, it was too
What
bad.
else is the tangent?
No, I was looking for the pattern.
Why
Okay. When you look at this, what do you see?
We just
Chain.
what do you call that?
I see A plus B product rule.
You see product rule? There's no
See,
product.
chain rule,
Chain rule, but like what do you see?
Constant.
A plus B. So you see a constant times x
Plus a constant.
plus a constant
To the power.
to another constant. That's what you see. What's the derivative of this? A, because a constant times x, the derivative is a constant. What are you supposed to do with the chain rule? You put the thing here in front, subtract 1, multiply the derivative inside, which is just the guy that's in front of the x.
Yeah.
Right? It's not scary at all, right? You don't allow yourself to be scared. You look at this, this is what you should see. It's just a form, right? Okay.
More scary.
All right, so how about, tell me the derivative of this in 1 second. 1 second. Same guy, sort of. What's the derivative?
Sine pi minus 1 times pi squared.
Oh wait, but it's all like sounding like.
Huh?
Can't be the same thing. Why would you write it?
Sine minus sine pi minus 1. Sine pi minus 1. You cannot do that. It's all sine pi.
I just did. I wrote
Because it's a power and that's not a constant.
Yeah, the power is
sine of pi plus
Is it just 0?
Wait, what's sine?
It's just 0.
Okay, now you're thinking too hard.
Is it just 0?
It's 0. Why is it 0?
The sine pi is 0.
This guy is 0.
Yeah, that's what
something to 0. This
Is
is really
1.
just equal to 1. I'm really just asking the derivative of 1. It's 0.
Oh, wow.
That's why I said you're gonna do it.
Alright, so that's another form. Sine pi 0. It's just like a knee-jerk reaction. Oh, that's serious. Alright, moving on to chapter 3, 3.1. Maximum and minimum values. Let's just jump into the definitions. F is a function then f of c is
That's C, E, D.
an element. Like set c in d.
Are C and D constant?
Huh? D is the domain. It's just like an interval, right? And c is just a number in that interval. I'll illustrate this here. C is an absolute. Okay, what I'm defining here is the absolute maximum and the absolute minimum, right? Basically, the absolute maximum is the biggest value on the whole interval, right? On the whole domain. And absolute minimum is the smallest value, right? This is just a point where the function gives us bigger value than any other point. So, to give some examples, just some illustrations, just to recognize them. So say there's this function, the domain is AB. There's another function with domain AB. Here's another function. Okay, there are other names these can be called. Instead of max or min. Sometimes they call them extreme points. So if you read the textbook, find the extreme values, they're talking about maximums and minimums, right? So you might see that there is also another thing that they, or in case of absolute max and min, absolute max or min are also called global max or min. Right, so you might see absolute, you might see global, so don't get confused when you see them. They're talking about the same thing. Extrema just means both, absolute max and min. Okay. So identify where the absolute max and min occur on these graphs. What about this one? Right in the middle, right on top here, right? This is the domain. Where's the biggest value? It's going to be this point. Whatever this y value is, we're going to call that f of c. That will be the absolute max. Right? Because it's the value that's bigger than every other y value. Right? What is the absolute min here in this function? F of a and f of b, which happen to be the same here, is absolute min. They are the smallest value on this whole graph. These 2 points have the smallest y value on the whole domain. What about here? What's the absolute max? F of B is the absolute max. F of A is absolute min. What about this graph? What doesn't exist? Right, this has no absolute max. Does it have an absolute min? F of A is the absolute min. Why does it not have an absolute max? It's going to infinity because this is an asymptote. So there's no y value that's bigger than any other y values because your y values just keep getting bigger forever, right? You can't just say, oh, this is the y value that's bigger than ever. Right? What about this one? None. No absolute extrema. Again, there's no y value on this curve that's bigger than all y values because it's going to infinity. There's also no y value that's smaller than all because it's going to negative infinity. What about this one?
Between A and B.
Huh?
B is the best, but
F of B is absolute max.
absolute is the dip, the lowest dip.
The lowest dip, right? We can call this like C, happens here, right? That's the y value that's smaller than every other y value. So C is absolute. That's basically the idea, right? The biggest guy is the absolute max, the smallest guy is the absolute min. They don't have to exist, right? So for functions that go up to infinity or down to negative infinity, you might not have one of these guys. But as long as they exist, this is what we call them. Right? It's the biggest and the smallest guys. Right? We want to talk about the behavior of functions in terms of the largest values they attain. Let's do some color definition. There's something called absolute max and min, and there are things called relative. And this happens if it's bigger than all guys for x near C. Another aka relative max or min are also called local max or min, right? Because you're dealing with a small vicinity. Yes, and by near x near C, I mean x is in some open interval. Right, so that means if your C is here, then you open some small open interval, right? Your x is going to be somewhere in that vicinity. So as long as you're close to C, C is the y value is the highest, you call it a relative maximum or relative. So I'll wait for you guys to write that down before I go on to the illustrations. Okay. In these illustrations, can you tell me where the relative maxes and mins are?
Relative max. The 2 points on the right.
Where? Like on top of the hills, right? Like these points are all relative maximums, right? They're not the biggest on the whole thing, but if you sort of zoom in close to them, they're the biggest in their little world, right? Their little space right there. Right? Same thing here. What about this point?
That's it's also relative.
This is also an absolute relative maximum, right? Because any open interval you take on either the left, no, that's not a relative maximum. Because this side, yeah. Right, because here, if you open an interval here, you'll notice that there's a point here that's higher than that one, right? So that's not a.
There was nothing on the left side.
If there was nothing on one side, like for example this point here, it's not considered a relative minimum. Because again, if you open an interval, there's no one over here to compare it to, right? Your relative minimums would be here, right? This is min. This is a min here.
But you can like keep zooming in and saying, oh, this is like the highest.
Yes, if you keep zooming in here, this will be the highest point always. Yeah.
So those points are absolute maximum.
Right, so is there an absolute max or min to this problem? There is no absolute extrema. Pick out something that you think is the absolute extrema. It's a hole, which means it's approaching a point, but it's never getting to it. Right? So you'll never be able to say, oh, this is the highest point. Right? It keeps inching towards something. And every time you put a limit on it, it'll pass it a little bit, but never enough to get to the highest point. Right?
And what are those points?
And because of this one, keeps going down forever, there's no absolute min either.
And what are those points?
Hmm?
The first one and the last one in the curve?
This?
No, the left one.
This one?
Yeah, this one.
This is nothing.
Nothing?
Yeah, this is nothing. What about this one?
Wait, I have a question.
Yeah.
So the things that you said, they're the relative maximum?
These guys are the relative maximums here.
Yeah, but if you go to the left, you see something that's higher.
Yeah, but I mean near it, right? If you zoom in, he's the guy that's on top of the hill.
Is there like a specific amount of space that we're going to consider?
Nope. Basically anything that looks like a hill or a valley is going to be an absolute max if it looks like a hill, absolute min if it looks relative max if it looks like a hill, relative min if it looks like a valley. Right. It means just if you zoom in enough, that guy is the smallest guy around. What about these? Right here, there's the absolute max, right? We already identified this as the absolute min. It's also a relative min, right? Because if you zoom in enough, he's actually the smallest guy around. Here, relative minimum, here, relative minimum, here, relative maximum, here, relative maximum, here, relative maximum. That guy is nothing.
Is the absolute max also a relative relative maximum?
This one is not because there's no one on the right side.
Okay. Oh, but the one that's on the left side that you said is the relative maximum. There's also nothing.
No, there is something to the left side of it. Right? This is part of the curve here. If I tweak this just a little bit to do something like, and then did this, now that is also a relative maximum as well as an absolute maximum.
So why is that open circle on the first graph? Why is that not a relative maximum?
This one?
Yeah.
Because you never actually attain that point. It's an
What about the
open,
point below it?
it's a hole.
No, I'm not, like, it's part of the line, right?
Right, but there's a hole here. Right, so let's say this is at the level of something like, I don't know, 2, right? It will never actually hit 2. It will always keep getting a little bit higher.
What about 1.999? The part that's part of the line.
Right, so if you're at 1.999, eventually it will pass it and go to 1.9999999. And past that and go 1.9999999, right? And no 1.999. There's no y value that's bigger than everyone else.
Oh, well, why isn't it relative maximum? There's stuff on the right and the left side.
Because again, it never attains a value that you can say is bigger than everyone else. Right? The absolute max just means it's bigger than everyone else on the whole interval that you're considering. Relative just means in a small window. But you can't say that there's a y value here that's bigger than everyone else in either case. Right? There is no biggest y value. Yes?
Would there be an absolute maximum if there's two absolutes and there's like this?
You mean like this?
Yeah.
Yes, this is the absolute maximum here. There's no absolute minimum.
Is this also a relative maximum?
Which one?
Or the last one? The one you just did.
This is also a relative maximum, yes. Right? This is both an absolute max and relative max. There is no absolute min. There's no relative min either. And as before, these are all stay the same. This here is the absolute min and relative min. These are supposed to be lower than that. These are just relative maxes. Remember, the point is you have to be able to say that this y value is higher than everyone else within some vicinity. You can't say that about this point because there is no highest y value that it obtains. Right? It's always trying to get to 2, but it never gets there. And any number you pick before 2, it will eventually pass that number. So let's just actually do this for some formulas. What if I ask you about y equals x? Or y equals x squared? Or y equals x cubed, or sin x. Should I put a limit on that or? Nah, let's do it in general. Of course. Because we all pass pre-calc, right? Y equals tangent of x. What do you mean you never took pre-calc? How did you get in this file?
Get a student in high school and a student in college.
What?
Student in high school.
Yeah, when you
Oh,
take
it's a kind of SAT score. You can get
They
pre-calc.
David jumped over the time.
Yeah, I skipped pre-calc.
Sometimes you don't take it.
No, based on your.
Based on
That's
your
terrible.
grades.
Grade for SAT score is one of
They
those.
jump you.
It was a bad choice, but they gave you.
I want to come, but it's me. That's dumb.
At least you're honest.
how do you skip it all?
Okay, y equals x. Where are the absolute or relative? Y equals x just looks like that. There is no y lies that's bigger than everyone, it keeps going up. There is no y lies smaller than everyone because it keeps going down. There is no extrema here. There's none in general. There's no relative ones either. What if I actually gave you an interval, like -1 to 1?
Max would be that,
Then this would be the absolute max, that would be the absolute min. There's no relative max.
Wait, that's filled in or that's
They're filled in, yes. If I didn't fill one in, then there would be none. Okay. What about y equals x squared?
we just have absolute.
So this guy goes up forever, but there's a point where it gets the lowest. This is absolute minimum. It's also a relative minimum. No max, right? Because it keeps getting higher. What about x cubed? None, right? Again, it keeps getting lower and higher. You can't put a limit on it. No extreme. What about sin x? -1 and 1, right? So sine looks like this. Keeps going on forever, right? The highest value it attains is 1. The smallest value it attains is -1. So absolute max is 1. Absolute minimum is -1. Can you tell me the points where these occur?
Yes, 0 at pi.
0, pi over 2, 3 pi over 2, 3 pi over 2.
So here at pi over 2,
And that's pi.
and this is
That's 2 pi.
3 pi over 2.
3 pi.
3 pi over 2 is here, remember?
5 pi over 2.
5 pi over 6.
This is 5 pi over 2.
That's 7 pi over 6.
What's the other one? This would be minus pi over 2. This would be what?
3 pi.
Minus 3 pi over 2. Can you tell me in general when these would occur? F of what is the absolute max?
Odd pi over 2. Wouldn't it be? Odd pi over 2.
Odd pi over 2.
It's not odd pi over 2 because 3 pi over 2 is not.
Well, 3 is an odd number.
3 is not, no?
Isn't it also relative?
Oh,
They're
okay,
both.
I can
This each of these is an absolute max and a relative max.
Relative to each other, absolutely.
Because that's the one is the biggest sine gets ever. Right? So it's also an absolute max. And locally, if you zoom in here, that's the guy on the top of the hill. It's also a relative max. or local maximum. Right? All you have to remember is that sine is periodic. What's the period? So it'll do the same thing. How far away? Huh? 2 pi, right? So once you figure out the first guy, pi over 2, all you have to do is add a multiple of 2 pi. This will always give you the absolute maximum. And if you figure out 3 pi over 2, add a multiple of 2 pi. This will always be an absolute minimum. And it will always be minus 1 and 1. What about tangent?
Asymptotes in the line in the x3.
Where are the asymptotes of tangent?
At 1.
No. There's pi over 2. What else is there? Negative minus pi over 2. What else?
3 pi.
Negative 3 pi over 2. And then positive. In other words, this one is all odd multiples of pi over 2. That's where it's tangent, and it looks like this. Right? It has none.
Yeah.
No extreme. How about this guy?
Wow.
Alright, so all my people who skip pre-calc, how do I graph that? How would a pre-calc student graph it? You're always like
You just add the 4, then x like x squared.
yeah, but I subtracted this. If you want to graph something, what is the first thing you do? Back in pre-calc.
I'll see this at x squared. I'll see this at x squared. We will just get a wider or something like that.
You factor this x squared, you get x squared minus 4. And then what? Difference of 2 squares, so this x minus 2x plus 2. And why would we want to factor? What does that help us get? The roots, right? To find, you find the x-intercepts and the y-intercepts. That's one of the first things you learn in pre-calc when you're graphing stuff, right? So you find the x-intercepts. Right, this means you set y equals 0. This means that 0 is equal to x squared times x minus 2 times x plus 2, which means that x is 0, or x is 2, or x is minus 2. Right? The y-intercept means x is 0, so this means you get y is equal to 0 to the 4th minus 4 times 0 squared, which is also 0. So if we're graphing this guy, I know the intercepts are going to be 0, they're also going to be minus 2, they're also going to be plus 2. How do I graph the rest?
U.
It's not a U. What's the end behavior of x to the 4th? As you approach negative infinity, what happens? It goes to positive infinity, right? So the graph is going up on this side. Same thing goes on up on this side.
It's like a little W.
What happens in the middle?
Oh.
It's a W. How do you know? You can plug in a number, right? You plug in minus 1 into this, you get a negative number. Plug in positive 1 into this, you also get a negative number. So you know your graph has to come down and go through that intercept because it's the next intercept. You test the value here, so you know it has to be below. But 0 is an intercept, so you have to turn around and come back to hit 0. Now you tested the number, it's below, so you have to turn back to go down here. But now you have to hit that too, so you turn back again, right? So the graph of this is like a W. This is going to be really important. It's like 2 or 3 sections later, but you need to remember how to graph this thing. Right? But now what do? We only cut it off between, we only care about minus 2 up to 3, right? So let's call that 3. And I don't care about anyone else. Where are my absolute max and absolute mins? Right. F of 3 is the absolute max, which if you wanted you can compute it, right? Just 3 to the 4th minus 4 times 3 squared, right? Where's the absolute min?
Yeah, the bottom.
The bottom of these guys are going to be the absolute min. They're actually going to be the same. And they're also relative. This is absolute and relative.
Would be 0 be an absolute max?
Zero here, the zero would be what kind of point?
I mean, a relative max.
It would be a relative maximum. So, I don't know what these points, I do know it's symmetric, so let's just call this C and minus C. And so, f of C and f of minus C. They're going to give us some value, but that's going to be the absolute min. Relative max is f of 0, which is going to be 0. And that's the only relative max. This is also equal to the relative. Now, a lot of times it's going to be very important for us to be able to find what these points are that give us these maximums and minimums. In pre-calc, we don't really know how to find them in general, but we are going to learn how to find them in general using derivatives. That's a couple sections away. But yeah, we'll stop right here. So we're going to go and think about this idea of absolute max and relative max. And be sure that you can graph things and identify them on the graph. We're going to get really specific on how to find them later on. We didn't finish, so there's no.